steps that I would take. That was 3, 5, 9, and 12. You guys managed to get 55 people in 11. For the first two. Okay, so for this first one, I did start it yesterday. Remember, let me just look at it. I did do those first few steps with you guys, so I'm just going to rush through them. You would obviously write bracket, bracket, plus bracket, bracket, and then pull out and simplify. Okay, so this was what you were meant to get when you actually simplified the first bracket. I did show you guys this step, right? And then going to 1 as well, which we'll do now. But then for the second bracket, guys, when you write it as sin x minus cos x times sin x minus cos x and FOIL them out, you will also end up with sin squared x minus 2 sin x cos x. And then plus cos squared x. Okay, those are the 3 terms that you get from FOILing out sin x minus cos x. Okay, those 3. Right, we'll get sin squared x minus sin x cos x minus sin x cos x plus cos x. Okay, so it would end up as that. So then guys, we said yesterday from the first, these 3 terms here are from the first bracket, right? We have a sin squared x plus cos squared x, which we know is equal to 1. Right, do we remember that? 1. Yes, sin squared plus cos squared is 1. And then we have this plus 2 sin x cos x that we got from the first bracket of these 20, right? So these 3 terms basically simplify to those 2. Okay, so here we have sin squared x plus 2 sin x cos x plus cos squared x. That is equal to 1 plus 2 sin x cos x, because of sin squared plus cos squared being equal to 1. Okay, now guys, the same thing actually happens with the next terms that you got from the second bracket that was squared. We again have sin squared x plus cos squared x, which again is 1. And we have a minus 2 sin x cos x. So here we are left with plus, it's a plus 1, right guys? Do we see that? Both of these terms are positive. Okay, so that's a plus 1 and minus 2 sin x cos x. So this, these 3 terms simplify to those 2. And that second one is coming from the sin squared plus cos. Okay. Guys, what happens if you have a 2 sin x cos x minus 2 sin x cos x? What's that? That's 0. Hey, it's like a 2x minus 2x. That is 0. So these 2 terms actually, when you simplify it, 2 sin x cos x minus 2 sin x cos x is 0. And what am I left with? 1 plus 1 is 2. And that is what we did actually have on the right-hand side. Right, increase on that, okay? Okay, the next one that you have to do was number 5. So I'm just going to write that one down. I did write it down on the piece of paper with some like hints of what you need to start with. So it was 1 over sin x and then minus sin x. And we have to show that that is equal to cos x over tan x. All right, so again, I would start by working on the left-hand side. And I'm just actually going to write it like this, 1 over sin x. I'm going to leave it like that for now. But minus sin x, I'm going to write that as sin x over 1. You don't have to do that in a separate step. I think yesterday I just actually did this in the question, right? And we wrote what we were going to do. Guys, you always need to remember when you are adding or subtracting a fraction, you have to mix the denominator. I'm going to write it on the side. I think I did write it yesterday, but we need to find the LCD. Okay, that's what we called it in previous grade. So we need to find the LCD. And then we need to change all our denominators to that LCD. And then we're going to write it as one fraction. I don't think you are adding and subtracting fractions. Maybe I should just add a big plus and minus fraction. And those are the steps that you're going to have to take. Right, it's the same when we're working with numerical fractions or other algebraic fractions. Now it's just trig fractions, okay? But the method stays the same. So you always need to find your LCD, you must change all the denominators to that LCD. And then once you have the same denominator, you can write it as one fraction. Because guys, again, if we're looking at what we're starting with, we have two separate fractions, but what we're trying to get is one fraction. Right? So does it make sense that we're going to have to write it as one fraction? Okay, we've got from two fractions to one fraction. So we are going to have to use that one. Okay, now guys, what do you think is the LCD of sin x and 1? Sin x, okay? So this one is already over the LCD, so I don't have to change my first fraction, okay? This one I do have to change. I want this denominator to be sin x. At the moment, it's 1. So I have to multiply this by sin x. But then in the fraction, whatever you do at the bottom, you have to do at the top. So I'm going to have to multiply what I have at the top by sin x as well. Now, I'm not going to put it together as one fraction yet. I'm actually first going to do that multiplication. But if you feel comfortable enough, you could skip this step that I'm writing down now. 1 over sin x. Again, that one is already over the LCD, so I don't have to change that first one. Minus, now at the top I have sin x times sin x, which is sin squared x, right? Over sin x. Okay, so that's the second step here. We've now changed both denominators, actually the second one, but we have the both denominators are the same. Now we can put it together over one fraction. Guys, remember when you do that, you don't actually change the denominator. The denominator is going to stay sine. Okay, we're not timing them, we are subtracting. So at the top, we're going to have 1 minus sin squared x. And at the bottom, we have sin x. Right, so now we at least have one fraction, which is what we're trying to get, but this fraction that we have doesn't quite look like the one that I'm working. Okay, so we're going to have to do something else in order to get into context of mechanics. What can I do, guys? What can I do at the top there? 1 minus sin squared x. I can change that to cos squared x, hey? Let me show you the note that we wrote yesterday. Cos squared x is 1 minus sin squared x. All right, so we have 1 minus sin squared x, change that to cos squared x. For my numerator, I'm going to change to cos squared x over sin x. Okay, we're definitely getting close, but we're still not quite there. Now guys, this next step is maybe a bit of a stretch, right? Because what we're actually going to do now, we're not going to change cos squared x to anything. Because you guys see, we have a cos x at the top there, right? We have a cos squared x, so we're almost there. What did we say yesterday is the same as 1 over tan x? Because you see, I'm supposed to have a tan x in my denominator, right? 1 over tan x is what? Can you guys check in that note? Cos x over sin x. Now I'm going to write this on the side. 1 over tan x was cos over sin. You guys remember that? We said that tan was sine over cos, but in swapping around, 1 over tan is cos over sin. So guys, look at what I'm going to do now. I'm going to rewrite cos squared x as cos x times cos x. Do you agree that it's the same thing, right? Cos x times cos x is the same thing as cos squared x, and that is over sin x. Now look at this, guys. Cos x over sin x is 1 over tan x. Difficult to visualize that if you haven't seen it, right? But I'm rewriting cos squared x as cos x times cos x. Guys, how did I know that I have to do that? I was looking at what's on the right, and I was trying to see what can I do here to turn what I have into what I need. Firstly, we need just a cos x at the top, not a cos squared x. All right? So that made me think, okay, maybe I can just change cos squared x to cos x times cos x, and then see what happens to that second cos x. But it was over sin x, right? So if you remember this, it's almost like a result of the second identity that we did yesterday. We just write it down. You can change cos x over sin x to 1 over tan x. So it can look like this. You have your cos x at the top times 1 over tan x. Or, if that is a bit confusing, you can write it like this. Cos x times 1 over tan x. Maybe that feels good to you guys. Right, we had our cos x at the top, which is the same as cos x over 1, right? Cos x. And cos over sin is 1 over tan. Now, if you're looking at either one of these two ways of writing it, we do eventually end up with cos x over tan, which is what we have on the right hand. Guys, doing this last step is difficult, but if you weren't able to do that, say you just got to this step, you still would have gotten 1 mark for that, 1 mark for that denominator, a mark for changing 1 minus sin squared x to cos squared x, right? The last mark would have been for somehow showing that you know that cos x over sin x, over tan x, right? So you could have gotten 3 out of 4 for this question if you didn't know how to do this last one. Okay, so that's the nice thing about these identity questions. They count quite a lot of marks, but every time you like put a fraction together, that's 2 marks. Every time you change tan to sine over cos, that's 1 mark. Every time you use this identity, that's also 1 mark. All right. So don't feel disheartened if you can get to a certain point and you don't know how to go further, you will probably get 2 or 3 marks for what you've done there. Okay. Can we find that one, guys? Next one that you had to do was number 9. Hey, yeah. Let's look at number 9. So we had sin x plus cos x over 1 plus tan x. Now is equal to cos x. Now I did give you guys a hint for this one yesterday. And guys, another thing is, if you don't know what to do, but use the tan, change tan to sine over cos. Alright? Now you guys will think that your tan that will give you a mark. So sin x plus cos x, I'm leaving my denominator, sorry, numerator, as it is for now. all I'm going to do in my first step is change tan to sine over cos. And now, like we wrote down yesterday, I'm just going to write it again, just in case you don't have it next to this question. If not, you can just write this down on the side. We have a compound fraction now, which is when you have a fraction within a fraction. So sine x over cos x is a fraction in our bigger fraction. So to get rid of this inner fraction, which we obviously don't want there, we're going to times the numerator and denominator. I think yesterday I wrote top and bottom. It's fine if you have that written down. By the denominator of the inner fraction. So the denominator of the inner fraction here is cos x, right? We all agree with that? Our inner fraction is sine over cos. So cos x is the denominator of the inner fraction. So guys, you have to multiply everything at the top and everything at the bottom by that denominator. So every single term, I am multiplying by cos x. Okay, so when you do that, you have sine x cos x from the first term there at the top, which is sine x cos x, plus cos squared x, right? Plus cos squared x all over 1 times cos x is just cos x, plus, so that's the reason why I multiplied every term by the denominator is so that this denominator is now going to get cancelled out by the cos x. So that's why we multiply by that denominator so that it can cancel it out. So from that term, sin x over cos x times cos x, because the cos x is cancel each other out, I'm just left with sin x. Guys, you might be tempted to change this cos squared x into 1 minus sine squared x. Okay, but if you do that, it doesn't actually work, right? It doesn't get you what you want. So let's look back at, and guys, also that's fine. If you change cos squared x to 1 minus sine squared x, and you see it doesn't actually help me, you can just change it back. Okay, don't panic. You can always just go back. What I'm going to do here, look at what I'm trying to find, guys, just cos x. Right? There's a lot of terms here. I mean terms at the top and terms at the bottom. I have 2 here and 2 there. I just want 1 term in total at the end. How do you go from multiple terms to 1 term? Factorize. That's what we factorize there at the top. So take out cos x as a common factor, hey? Cos x is there and cos x is there as well. It's cos squared x. So let's do that. We're going to take out cos x as a common factor. At the top, if I say sin x cos x, and I take away the cos x, what's left? Sin x. Plus, cos squared x divided by cos x is going to give you cos x. At the bottom, I can't do anything there, guys. You can't use your sin squared plus cos squared identity because they're not squared. Okay, so we're just going to have to leave it like that. Cos x plus sin x. But now what do we notice, guys? We can just put brackets around here, hey? Group it as 1 term. What's happening there? Sin x plus cos x is the same as cos x plus sin x. So we can cancel out those 2 brackets. And what am I left with, guys? Cos x, which is what I did have on the right hand. Guys, often with these questions, You are trying stuff out. When I'm trying to change cos squared x to 1 minus sine squared x, it doesn't work, so then you're going to have to try something. Okay, so that's something that we do need to remember, guys, is that factorizing is still a thing. You might not have to factorize in your first step, all right, but you might have to factorize like we see here later on. Any question on that? All right, number 12 is the last one. And then I'm just going to give you guys some more things to practice. We're not moving on to something today. We are going to have to move on to something new tomorrow, though. And number 12, are you guys okay? All right, that is number 12. Guys, we ran out of time yesterday, so I didn't give you a for this one. So just looking at that left-hand side there, what do we think? What can I do there? Yeah, I can change tan to sine over cos. There you already have one off, even though you don't actually know what you're doing, okay? So we don't know yet. We are going to find out. Okay, so the first fraction I'm going to leave as it is. So cos x over 1 plus sine x plus sine x over cos x. First one here. The first thing that we can change. Now guys, at the moment we have no squares, we can't really change anything there, hey? I can't change sine x to anything, I can't change cos x to anything. If they were sine squared x and cos squared x, we could use that identity. But now we need to look back at what am I actually doing. I have two fractions that I am adding together. So we must find the LCD. Okay? So the LCD of this is a bit more complicated, guys, because you have basically a bracket and cos x. Right? So your LCD is actually going to be cos x times 1 plus sine x. Remember the LCD is the lowest common denominator. It's actually the lowest common multiple of your denominator. So it has to be something that, in this case, both, because we have two, both of these denominators need to be able to divide into our LCD. All right, so you have to have cos x in your LCD so that cos x can divide into it, and you have to have that 1 plus sine x in your LCD so that 1 plus sine x can divide into it. Okay, so you do have to include both of those as well. So now, guys, we need to ask ourselves, what if I multiply the bracket by to turn it into the LCD? Cos x. So I must multiply the bottom by cos x to turn it into the LCD. And whatever I do at the bottom, I have to do at the top. So the next fraction, what must I multiply cos x by to turn it into the LCD? 1 plus sine x. In brackets, right? 1 plus sine x. And again, whatever you do at the bottom, you do have to do at the top. Okay, next step. When I do this multiplication, this first fraction is going to be over my LCD. So cos x times 1 plus sine x. And at the top, what am I going to have if I say cos x times cos x? Cos squared. Plus, for my next fraction, I'm also going to have the LCD as the denominator. So cos x times 1 plus sine x. And at the top, What's sin x times 1? Sin x, and sin x times sin x is sin squared x. So I'm going to multiply that sin x into that bracket straight away. But you could have first just written it as sin x bracket 1 plus sin. Okay, so you could have just written that with the bracket next to it. I multiplied the sin x straight away. Okay, it's up to you. However, we have the same denominator, so now we're going to write it as one fraction. Again, we started with two terms, we want one fraction in the end. Okay, so this is similar to number, was it 5? That we did before, it's a bit more complicated. So now we have the same denominator, so my numerator is now going to be cos squared x, because there's a plus in between the two fractions. I'm going to put a plus there, sin x plus sin squared x. And in my denominator, it's going to be the LCD. Remember, you don't change the LCD when you put it together as one fraction. Only when you times in fractions do you change the denominator. Okay, when you're adding and subtracting, you leave the denominator. Okay, now what? Remember what we're trying to work towards, right? 1 over cos x. So all of this stuff at the top and this bracket actually we need to try and get rid of. We just want 1 at the top and cos x at the bottom. What do you think? You could find that bracket out, but let's first just talk about what's happening at the top. Yes, well done. Cos squared plus sin squared is 1. Okay? Cos squared x plus sin squared x is equal to 1. Let's do that. At the top, we're going to have 1 plus sin x. Right, before I multiply the bracket off at the bottom here, don't I have 1 plus sin x as a bracket already? So do you think I have to multiply that cos x in? No, if I leave it as a bracket, I'm going to be able to cancel it out, right? So we're going to leave that as cos x times 1 plus sin x. Close bracket. At the top, you can just leave brackets around that. And now we can cancel it out. 1 plus sin x and 1 plus sin x. And what's left at the top if there's nothing left? If I cancel everything out, a 1, right? And at the bottom, what's left? Cos x. Which was the right hand. Okay, I was fine about that, guys. So, yeah, things to look out for. If it's two fractions, LCD, put them as 1, see what happens, right? You always need to be on the lookout for those identities, right? You need to always check, is there a cos squared plus sin squared that you can change into a 1? Or sometimes, is there a 1 that you can change into a sin squared plus cos squared? All right, that might also happen. Can you factorize by taking out a common factor? Can you do a difference of 2 squares? Right? Do you have a bracket at the top and the bottom that you can cancel out? Okay, those are things that we always need to be on the lookout for. Okay, I'm going to give you a few more of these to practice for tomorrow. And guys, I know it's daunting. It's not easy to get into these at first, but really the only way to be able to do it if you practice. Okay, the more of these you do, the easier it gets to actually notice what you have to do. You will start to see patterns, and if it's this type of question, I have to do this. But the only way for you guys to do that is to actually try it on your own. And guys, like I said also, say for example, here you decided to multiply the cos x in, right, into the bracket. You would get, I'll just do it on the side here. If you had 1 plus sin x at the top, and then at the bottom, If you decided to multiply the bracket in, because you might want to do that, you would have cos x plus sin x cos x. Now that's not necessarily the right way to go about it, but it's not the end of the world. Now you would look at this and you say, I can't actually change anything, right? I can't change this to, there's no squares anyway, right? I'm kind of stuck. I can't do anything. So then, guys, if you're stuck, then you look for factors. Okay, you'll just have to work backwards. You will then just have to take this cos x out again as a common factor, which will get you back to this thing. Okay, it's just one step more, but it's not the end of the world, guys. Often with these questions, there might be different methods to get to the answer, or if you make a mistake, you can always undo it. Okay, by going backwards, by trying something else. All right, so it's the same exercise, page 144, but now I would like you to do numbers. Let's see. Let's do number 6. Mhm. Um, and then from the next exercise. So I'm not going to exclude you guys finish for these ones, right? I want you to look at the question, try and figure out what you have to do next. But if you can't think of what's actually going to work, just do something. Okay. I really don't want you guys to leave these questions out because it's so easy to just get a mark for applying an identity, even if you don't always done. Okay. So do something at least. If you can factorize, factorize. If you can change it using an identity, do that. If you can put two fractions together, do that. Okay.